Hello everyone, this is Liang, and Airbnb Experiences is a two-sided online marketplace for travel, and we have all kinds of experiences. And for example, like a cooking, like animals. Also, it's available in many cities around the world. And when a user types in the query on Airbnb, like Barcelona, there are two questions we want to answer. And the first one is, what's special in Barcelona? And the second question is, what's the user's preference? And we are going to answer these two questions in this paper, in this presentation. And the title is How Airbnb Tells You Will Enjoy Sunset Sailing in Barcelona, Recommendation in a Two-Sided Travel Marketplace. And I'm Liang, and this is a joint work with Mihalo, and we are both from the relevance team of Airbnb. And the first question is, how do we find sunset sailing in Barcelona? So we have experiences across the world, and we listed some top cities here like Paris, like London. And we also have all sorts of experiences. And we try to group these experiences so that like it's easier for users to browse. For example, like we have groupings like art and culture and entertainment and food and drink and nature. And these groupings are supported by our knowledge graph. So this is like a illustration of the knowledge graph, and it's structured like a tree. And the first column is are those like a top level concepts like art and culture, entertainment. And under entertainment, we have like a comedy dance, and under dance, we have like a ballet, and we have like a Latin dance and disco. And this knowledge graph was built manually, and we intended to include like those universally popular concepts. So it doesn't include those city-specific or location-specific concepts. And one question is, why do we need city-specific concepts in a knowledge graph? And we can see like this is a snapshot of like a city homepage. So basically, when a user browses a city and tries to browse like what listings are available, we try to use these cards, like groupings of experiences, to help like promote the listings there. And we can see like we have something like classes and workshops, we have sports, outdoors, food and drink. Like it is good, it is not bad, but it doesn't have the feeling like when you are traveling in a new city, you want to see like what's special. Like I don't want to see like in every city's classes, workshops, and sports and outdoors. And if we can have these city-specific concepts, and then we can like better advertise the listings. For example, this is an example from Mexico City, and we can see. So instead of like city tours, we have Teotihuacan pyramids. And instead of food and drinks, we will have like a mezcal tastings and the taco tours. And so these are both like Mexico City specific. It's a special there. And also like instead of sports, we have like a lucha libre. This is like the traditional Mexican wrestling. And the last one is Xochimilco. So it is like a neighborhood in Mexico City, so famous for the canal. So we believe like if we can show these like city-specific concepts and city-specific groupings, the users will feel like it will be like a more likely a user will click on these groupings and to discover like what's special in the city. And like take one step back and let's try to define like what is a great city-specific concept. And so we think like a city-specific tag or city-specific concept should be, first it should be well known to the location among Airbnb users. And second, it should be specific to a particular city. And third, there should be enough listings associated with the tag, associated with the concept. So we want to advertise for grouping that has no listings. And also we hope like the tag listings should be popular. Here by popular, we mean so the listings are booked frequently. So we want to see groupings of listings that are well known to users and specific to a particular location, and we have enough listings to support grouping, and the listings within the grouping are frequently booked. And based on these rules, or based on these like metrics, we propose a heuristic-based method. So this is the algorithm, and in step 2, we extract the key phrases from the listing titles, descriptions. And for all the extracted words, we try to estimate the location frequency and the inverse location frequency based on the location. So this is very similar to the TF-IDF, but instead of documents, what we have is like a location as a document. So basically, we try to find, for each word, we try to find how representative it is to a location. And also, we don't want it to be like a keyword that's popular across the world. And in the step 7, we define another 2 metrics. The first one defines the popularity. So this popularity is defined based on the Google search trends. So we want to highlight these keywords that are like frequently searched with the location. And the last one, this is the bookability. So basically, we try to estimate how frequently the listings associated with each tag are booked. And finally, in step 8, we times these things up, and we try to estimate which keyword is like a city-specific tag for a particular location. And this is an example listing. So for example, this is the title, Golden Gate Bridge Walking Tour. And under the what you will do, it is the description of the listing. So in the, we try to extract the key phrases from these 2 parts. And here are some results we discovered using this method. And for example, in Paris, we found something like Eiffel Tower. And in Kyoto, we found the Fushimi Inari. And in Buenos Aires, we found Palermo. It is like a neighborhood of Buenos Aires. And we also found football. So we already know, before we use this model, we already know sports is popular in Buenos Aires. But actually in Buenos Aires, the most popular one is football. And also in Bangkok, we found Thai cooking tuk tuk. And in the last row, we found the sunset sailing in Barcelona. We already know sailing is popular in Barcelona and also in many other cities. But in Barcelona, the specific, a special thing is a sunset sailing. And so now we jump to the second question. So how do we tell the user's preference? So in Airbnb Experiences, one of the key features we can use for the recommendation model is the location features, and they are categorical features. And but when we try to test the model's recommendation effectiveness in different markets, we were surprised that the model underperforms in some specific market. In this figure, each row is a local market, and we could apply the global model on this local market, and we can see these are negative values. We can see the model's performance was the model underperforms in these local markets. And what causes the problem? What is the prominent guest problem here? And Airbnb Experiences started from United States, and the majority of our guests are from United States. So you can imagine the majority data is generated by the American customers. And so the algorithm, trained based on the best data set, caters largely to a US audience. And as we become more and more international and more guests are from non-US markets, and this caused the problem that the guests from emerging non-US markets do not resonate well with the results that are surfaced to them. So in order to solve this problem, so what we do is we try to deal with the location features using submodels. For example, this is how we do it, using a GBDT model. So if the production model is a GBDT model, so what we can do is we still keep the global model, like the model trained on the global data, but we added some sub-models, sub-trays. For example, this sub-tray is for the US market, and this sub-tray is for the France market. Then this single sub-tray is tries to correct the previous global model only for the the France market, and it is also independent with other local models. And similarly for the neural network, what we do is we add these sub-models so the first tower is like the global neural network model, and then we added some sub towers, sub models for different markets, like for country 1, country 2, country 3, and we will use some gates to control which model will be triggered based on the country information. And we first test these models offline, and we compare with binary coding and embedding and the multi-model. So you can see we have all different kinds of methods, but these are all variants of GBDT and neural network. And BC stands for binary coding, and E stands for embedding. We also use multi-model. Multi-model means we train a model for each country, train a kind of a global model for each country, and the last two are the proposed methods, and for neural network and for GBDT. And we also tested using two groups of users, logged-in users and logged-out users, since their feature set is different. And we found a consistent pattern that the best method is the GBDT model, the GBDT model with some models. Then we tested the GBDT model online. So we tested the model on the global users of Airbnb Experiences. So all the users are in this experiment, and we ran the experiment for about 3 weeks, and we use 8 metrics to measure the effect. So including the revenue. In revenue, we have gained the 3.9% gain, and the gain is also statistically significant. And this 3.9% gain concludes this experiment to be the most influential single experiment in 2019 in lifting the revenue of Airbnb Experiences. And we also have 2.9% gain of bookings and 1.2% gain of number of bookers. And these three are all statistically significant. And we also have positive results on new user booking and the number of new bookers. And also we have positive results on the C-days behaviors, truth-days behaviors. And we have a statistically significant improvement on the wish list behavior. So in order to dig deeper into the results, we also show how the confidence interval changes over time. And in this graph, so this figure is based on the revenue, the total revenue of booked listings. And the y-axis is the delta of the treatment group comparing with the control group. And we can see in day 1, actually the control group outperformed the treatment group. And but the confidence interval is not the confidence interval is is quite wide. And from day 2, we can see the treatment effect is positive, and then the purple area is the confidence interval. And after about 10 days, the model consistently outperforms the baseline algorithm. And I want to talk a little about the connection between the two parts. So the extended concepts of the knowledge graph can be used as a personalization feature for the submodel for the proposal model. But on the other hand, these two parts are also a little independent from each other. For example, the concepts, the extended concepts of the knowledge graph can be used to build these like groupings for like promoting the listings in the city homepage. And in conclusion, we propose a heuristic-based method to discover location-specific concepts to expand the knowledge graph. And also we propose a submodel framework to deal with the location features. And these models, these two models are quite like simple. It's not like complicated model, but we try to design the algorithms to solve business problems. And in the future, I think there are many promising areas. For example, like how do we measure the quality of a new knowledge graph concept for e-commerce? And also like how do we discover the best categorical features to build submodels, and also like how to build the submodels. And we would like to thank the relevance team and experiences team at Airbnb for their support, and especially Eric, Chunhao, Dylan, and Jimmy and Bo for helping review the results and helping set up the experiment. And if you are interested in our work, please visit our engineering and data science blog. And if you have any questions about the work, feel free to reach out to me, and I leave all my contact information here. And yeah, that's it. Thank you.